You can unmute yourself, sir.
Okay, fine. Um, okay, if you can see my screen, I just brought this quickly because what I was looking for, I couldn't lay my hands on it. I'm going to treat, I'm going to show you an example of, I will show you an example of me and, and uh, mean, variance, and standard deviation of an ungrouped data. You know, before the network started misbehaving, I was trying to show you how to find the variance and standard deviation of an ungrouped data. So, and I was trying to particularly explain how at times the formula is divided by n, y at times it is divided by n minus 1. The gospel truth is that if you are dealing with a whole population, if you are dealing with a whole population, and you are asked to find the variance and standard deviation, you divide by n when you have a whole population. That's why we say population variance sigma square is equal to the sum x minus x bar bracket close square all over n. And the standard deviation, of course, you know, is the square root of the variance. The standard deviation is the square root of the variance, which is given by this. Now, if the question says find the sample variance, find the sample variance. The sample variance is s squared is equal to some x minus x bar squared all over n minus 1. N minus 1 because you are dealing with a sample, not the entire population. In this case, your standard deviation is going to be the square root of your variance. So let me pick an example quickly to drive my point home before we go into finding the mean, variance, and standard deviation of a grouped data. So this is an ungrouped data. 2468 is an ungrouped data. Find the variance and standard deviation of the following data. You have 2, you have 4, you have 6, you have 8. Now, step 1, the very first bold step you are going to take is to find the mean of this set of numbers. And the mean is gotten as a result of adding 2 plus 4 plus 6 plus 8. You divide by 1, 2, 3, 4. When you do that, if you add all this, you have 20 all over 4. And obviously, this is 5. Now, all the grammar I was speaking the morning about variance and standard deviation of an ungrouped data. This is how to present it in a tabular form. I will get the other typed one. Then I will give like 2, 3 examples of an ungrouped data. I will update the notes, then give you, I will type it neatly, then send to you. And if possible, give an assignment on it so that you take your time at home to familiarize yourself on the steps involved in finding the variance and standard deviation of an ungrouped data. Now, you have your 2, 4, these are the set of numbers here. You have your 2, 4, 6, 6, 8, 6, 8. Next, you create a column for x minus x bar. And how do we get minus 3? It's this 2 here. You know your x are all these values here. Your x bar is this 5. Your x bar is this 5. Therefore, 2 minus 5 gives us minus 3. 4 minus 1. 4 minus 5 gives us minus 1. 6 minus this 5 here gives us 1. 8 minus this 5 here gives us 3. How do we get this column? This column, the heading says x minus x bar squared. The implication is that all the values here will be squared. What do we mean by squared? Minus 3 squared is equal to minus 3 times minus 3, which gives us 9. Minus 1 squared is minus 1 times minus 1, which gives us 1. 1 squared gives us 1. 3 squared, plus is 3 times 3, gives us 9. So immediately what you do, you add up all these values. That's why we say sum x minus x bar square. This meaning of sum x minus x bar square is that all the values in this column, you add them up. And when you do that, if you add these values up, you will have 20. Next, we deploy the formula for population variance is 20 over 4. Why is it 20 over 4? 20 over 4 because you are not subtracting by 1. I'm not saying n minus 1, so it's population variance. So we'll just use the 4 directly. This is the formula I'm using. So you have 20 all over 4, which is 5. And of course, the standard deviation is the square root of 5. So sigma square is equal to 5. Only sigma is the square root of 5. And the square root of 5 is 2.236, 2.236. For the sample variance and standard deviation, for sample variance and standard deviation, you have s squared is equal to 20 all over 3. Now, why is it 20 all over 3 and not 4? If you go back to the formula for sample variance is n minus 1. And of course, you know that your n is 4. Since your n is 4, 4 minus 1 gives us 3. And 20 over 3 gives us this. S squared is equal to 6.667. And of course, only s is the square root of 6.667. And this is the result. This is the result. So this is how to find variance and standard deviation of a data that is not grouped. A data that is not grouped, this is the approach you use in finding the variance and standard deviation. If you have any question here, you ask me before we go to finding mean, variance, and standard deviation of grouped data. Anybody that wants to speak, just raise up. John, you have the floor, please, John. Unmute yourself and ask your question. John, unmute yourself and ask your question. It's raising up his hand.
Unmute yourself.
Oh, okay. Thank you, sir. My question is that what is the difference between the group data and the ungrouped data? That's my question, sir.
This is it. This data is not grouped because a group data is such that if, for instance, I have 2 here, where we'll need frequency, and under frequency I'll put 2. Here, if I wish to group this data the way it is like this, as I'll write 2, I'll put 0 as the frequency. As I write 4, I'll put 0. Write 6, I'll put 0. Write 8, I'll put 0. Just watch this set of data. I'm going to show you the difference between grouped and ungrouped data now. A group data you have 10 to 12, the values that range between 12 to 14, the data is grouped. So you have the frequency. 15 to 20, you have a frequency. 17 to 30, you have a frequency. In that case, the data is grouped. The numbers are grouped. But in this case, they are not grouped. They are just scattered. They are just in a distribution. Yasi, David, you have the flow. Ask your question. Please, this is the time you ask all set of questions you want to ask. It's not on the exam day. I'm ready for you now. Ask your question. Anywhere you are not clear, you let me know so that I can throw more light. Class rep, if you have the pass, you can unmute David. David is raising up his hand. He wants to ask question.
Yeah, can you hear me, sir?
Yeah, I can hear you. You just mute yourself again.
Okay. Yeah, thank you. Yeah, I wanted to ask the formula for sample variance. I discovered that it's the same thing that we use to calculate standard
I
deviation.
can't hear you very well, please. I can't hear you very well.
Okay, so what I'm saying is the formula for sample variance, is it the same thing for the formula for standard deviation?
This is sample variance. Standard deviation is the square root of variance. This is standard deviation. Now that's why I say SD. SD means standard deviation. S square is the whole of that. And if you want to get standard deviation, all you need to do, you just take square root on both sides. If you take square root on both sides, you have S equals to the square root of all that. And when you say S is equal to the square root of all that, you're talking about standard deviation. Any question? If there are no further questions, let's make progress. Any question? So this is the mean and this is the variance and standard deviation for both population variance and sample variance. So anywhere you see n minus 1, you should be able to know why it is n minus 1. It is n minus 1 because it's just a sample of the entire population that is put into consideration. But if you are talking about the population variance, you are looking at the whole entire population, then you use all over n. So if there are no further questions, let me share my screen again. I'm Xing this so that I can get what I really wanted to do for today. Okay, Yev, you have the floor.
While I unmute yourself.
You have the floor, please.
Hello? Hello?
I can hear you.
Okay. Yes, I want to make a contribution.
Okay.
Okay, yes. And the contribution is this, that the variance, which is S squared, or S to power 2, is called the summation of all of these things. Now, it means that S to power 2 is variance, while S alone is the standard deviation. And if you already gotten your S, if you have already gotten your S to power 2, which is variance, for you to get your standard deviation, which is single S, you take the square root of the S squared for you to be able to get your standard deviation for the S.
Yes. Yes. You are correct. If there are no further questions, let me share my next screen, please. Class rep, do I have the powers to do that?
Sir, you are in charge, sir.
No, if you are not clear, I can't make progress. So I want to be sure that you are okay, then I can make progress. So I'm Xing this.
Let's make progress. Let's make progress.
Yes, I'm Xing this one now. I just hope what happens in the morning doesn't repeat itself. Okay, this one has gone. I've Xed it. Some persons are saying they can't hear me. Can you hear me now? Class rep, can you guys hear me? Can you hear me? Can you hear me loud and clear now?
Sir, we can hear you, but the audio is very low.
I'm coming. Bana, can you hear me?
Yes, sir, we can hear you, sir.
It's not low any longer, isn't it?
Yeah, it's better.
So let us quickly look at mean, variance, and standard deviation from grouped data. Now, let F equal frequency. F equal frequency, X is equal to midpoint, and N is equal to the sum of F. So X bar is equal to the sum of F of X all over the sum of F. That's the summation of the frequency times the midpoint all over the summation of the frequency. Variance sigma square is equal to sum fx square all over sum f minus x bar square. Standard deviation sigma is equal to the square root of variance. Don't be scared. When we take a practical example, you understand what I'm talking about. The person asking about grouped data, this is a grouped data. This is a grouped data. what you saw earlier on is ungrouped. It's not grouped, but this is a grouped data now. And as an example, example 1 says a researcher recorded the ages in years of 20 people and summarized the data as shown in the table below. Ages, of course, and years. Those between 10 to 14 years are just 3 of them. Those between 15 and 20 years are just 5. Those between 20 to 24 years are just 7. Those between 25 to 29 years are just 4. Those between 30 to 34 years are just, it's just 1 person. Now the question says, find the mean, variance, and standard deviation of the ages. Find the mean, variance, and standard deviation of the ages for grouped data, for this grouped data. Now, as a solution, this is how you construct your table. The ages is what I'm calling class here. I'm calling it class because it ranges between 10 to 14, 15 to 19, 15 to 19, 20 to 24, 25 to 25 to and 30 to 34. So this is the frequency. We have 3, we have 5, we have 7, we have 4, we have 1. So the frequencies are outlined here. The frequencies are here. Midpoint X. The midpoint is what I'm calling X. Maybe subsequently I will just call it X. The midpoint is X. Now, how do we get these midpoints here? Look at this class interval. 10 plus 14. 10 plus 14 divided by 2 gives us 12. 10 plus 14 divided by 2 gives us 12. How do we get f of x? 3 times 12. This 3 here times 12 gives us 30. 3 times 12 gives us 36. How do we get x squared here? You square the midpoint. 12 squared. The implication is 12 times 12 gives us 144. 12 times 12 gives us 144. 12 times 12 gives us 144. How do we get fx squared? Your frequency here, your frequency times 144 gives us 43. Similarly, 15 plus 19 divided by 2 will give you 17. Now, to get the value for f of x, fx, you simply multiply 5 times 17 gives us 85. Gives us 85. Now, how do we get this value? You will square 17. And 17 squared is simply 17 times 17. That will give you 289. 289. How do we get fx squared? F is 5. X squared is 289. When you multiply that together, you get 1445. 1445. Any question? And that is how we did all the arithmetic and came down to 30 to 34. And we got 32, or 30 plus 34. Divided by 2, you have 32. Fx is simply 1 times 32, gives you 32. Squared is simply 32 squared is simply 32 times 32, gives us 1024. Now, fx squared, take your value for x, you take your value for f, you take your value for x squared, and you have this value. Any trouble so far? If you have any question, you ask so that we can make progress. Yes, Chair. Yeah, Benjamin, you have the floor.
Okay, good afternoon, sir.
Yeah, good afternoon.
Sir, it's well understood, but I don't know where did you get the 2 that you divide? You say 10 plus 14 divided by 2.
Yes, it's an approach. It's a formula. The formula for finding midpoint is lower limit plus upper limit divided by 2. That's the formula. In this case, the lower limit for this class interval, the lower limit is 10. The upper limit is 14. And the formula says midpoint is equal to lower limit plus upper limit divided by 2. There's a proof for it.
Okay.
It's just like quadratic equation formula. We say if you have ax squared plus bx plus c equals 0, that's the general form of a quadratic equation. So to find, when you solve using completing the square, you get x is equal to plus or minus b squared minus 4ac all over 2a. So it's just that you're asking me where do I get that formula from? It's from a proof. So sorry, my network went bad. Let me share my screen again. Go. Don't worry. Go. Can you see my screen now? Wonderful. Any further questions so that we can make progress? Let's see what the charts are saying. Okay. The charts are saying progress, sir. Okay, fine. Now, the next thing is quickly, what we need is in the formula for me, we need this column. for me, you need this column, you need this column. Then for you to get the variance and standard deviation, you need F column, you need F of X, Fx, you need Fx square column. You need all this column. So the summation of F, that's you sum all the frequencies, you have 20. If you sum all the frequencies, you have 20. Then if you sum F of X, you sum F of X, you will have, if you sum F of X, you will have 415. If you sum Fx square, or if you sum all of this, you will have 9205. 9205. Now, quickly, the mean, which is denoted as X bar, the mean, which is denoted as X bar, is equal to some Fx all over some F, which is equal to your 415 here, your 20. 115 divided by 20 will give you 20.75. For the variance, which is sigma squared, for the variance, which is sigma squared, you have some Fx squared all over some F minus X bar squared. And this is equal to, if you watch closely, your sum Fx squared is 9205. We have our 9205 there. Our sum F is 20. Sum F is 20. This is our 20. X bar squared. You recall X bar, which is our mean, is 20.75. You have 20.75 squared here. And 9205 divided by 20 is 46.25. 46.25 minus this, your minus sign, look at it here. So 20.75 squared is the meaning mathematically is 20.75 times 20.75, which will give you 430.5625, which is equal to, when you do this small arithmetic, you get 29.6875. 29.6875. 29.6875. So this is the variance. Your standard deviation is just requiring you to take the square root of this number. That's why I say standard deviation, sigma is equal to the square root of sigma squared. Of course, you know that your sigma square is your variance, which is this value. All you need to do is to take the square root of this number, and you have 5.45. I rest my case. If you have any question, you ask. Otherwise, we'll make good progress again. Let me see what the charts are saying. Add each of the class age and divide by 2. For example, 15 plus that. Yeah. Mary added to 2. But there's no percentage anyway. It's just, okay, she wanted to press divide and she wrote, okay, 430.56 is from where? Let me show you. Once again, you see, this is the formula. Variance, which is sigma squared, is some Fx squared all over some F minus X bar squared, which is equal to This your sum fx squared is here. This value is here. Put it there. Then sum f is 20. You put it there. Your x bar squared. Your x bar alone is 20.75. 20.75, which is yeah, 20.75 squared is there. So if you divide 9205 by 20, you have 460.25. This is your negative sign. Look at it here. 20.75 square is simply saying that you should double this number, which is 20.75 times 20.75. 20.75 times 20.75, you will get 430.5625. And when you perform this simple arithmetic, you get 29.6875. Somebody said I should go through the variance again. Please, how do you differentiate between population variance and will the question specify? Yes, the question will specify. It should be noted that variance formula. Let's see what this person. It should be noted that the variance formula is a shortcut formula. It can also be written in another way. Okay. The person that said I should explain variance, let me take the next example. Maybe from the next example, you'll be much more clearer. Now, the scores of 30 students in a test were grouped as follows. The scores of 30 students in a test were grouped as follows. 40 to 49, you have 2. So 40 to 49, you have 2. 50 to 59, you have 6. 60 to 69, you have 10. 70 to 79, you have 7. 80 to 89, you have 4. 90 to 99, you have 1. The question says that you should find the mean, variance, and standard deviation of the scores. Find the mean, variance, and standard deviation of the score. So all we need to do is to first create the required table. And this is the table. Your class interval, you put your class interval on this column first. You put your frequency on this column. How do we get the midpoint? The midpoint is simply adding 40 plus 49. That is the lower limit plus the upper limit divided by 2. You have 44.5. 40 plus 49 divided by 2, you have 44.5. Now the column for f times x is simply you taking this 2 multiplying by 44.5, and that will give you 89.0. How do we get x squared? Is simply taking the midpoint, which is x, and squaring it. If you do that, you will have 44.5 times 44.5, which will give us 1980.25. 1980.25. Now, fx squared gotten from, take this your frequency value, you multiply by x square value, which is 1980.25. We do that, you will have a 3960.5. And that's how we'll maneuver for the rest of the values up to 90 to 99. Frequency is 1. And if you want to get the midpoint is 90 plus 99 divided by 2. You have 94.5. And how do we get our f times x here? Simply you taking this 1, multiplying by 94.5, which is this. Now x squared is 94.5 times 94.5. You get this value. Now, how do you get this fx squared? The value for f times x squared is you taking the value of f1 multiplying by this value of x squared, which will give me this value, which is 8930.25. 8930.25. So quickly, without waste of time, I need this column. I need this column. I need this column. And I will add everything up. So just the summation of just the summation of f, I have 30. The summation of f of x, I have 2015. The summation of fx squared here, I have this value. And quickly, without waste of time, the mean is sum fx all over sum f, which is equal to 2015, just here, all over 30. This is all over 30. We have 67.1667, which is approximately 67.17. 67.17. Now variance. Sum fx squared all over sum f minus x bar squared is simply you take this value here, you put there the value for sum f, which is 30, you put it there. The value for x bar, which is 67.1667, is squared equal. When you do this simple arithmetic, this divided by 30 gives us this. This squared gives us this. So when you perform this simple arithmetic, you have 146.22. That's the variance. And of course, without time wastage, the square root of variance will just give me my standard deviation. If you have any question, you ask. If you have any question, you ask so that we can make progress. So you can chat up in the box. Let me see what the box are saying. Mohammed, you have the floor. Mohammed, you have the floor. Mohammed, you have the floor. You can be sending in the chat so that I can know what you're talking about. Class rep, any question? If there are no questions, can I X this slide and move to the next subtopic? The person asking the significance of variance and standard deviation. The significance is that it helps us to know how the student, like in an exam scenario, it helps us to know how the student performance deviates from the mean. It helps us to know how the performance deviates from the mean. That is how people are far from the mean. I give you an instance. If, for example, in this class, just like as I was saying in the morning, if at the end of ENS, at the end of ENS 803, at the end of ENS 803, and when I took the average of the class, I discovered that the average is 65. That is the mean average of the class is 65. What I'm going to say is that the class average is 65. So, but if somebody asks, how far, how many student performance are away from the mean? That is how many students did not score the mean grade. That's 65. How many students deviated from the mean? That means I have to get the variance, then find my standard deviation to know the deviation from the mean. And the deviation in this case from the mean is 12.05, 12.09. That is how far the scores deviate from the mean. But if everybody, let's say we have 65, 66, 61, 7, 63. If we are asked, if you take the average, we'll say the deviation from the mean is 2 because the mean grade is 65 and the deviation is just 2. And some persons got 67, so the deviation from the mean is 2. So that's how you can interpret it physically. If there are no further questions, I'm Xing this slide to move to the next slide. Can you see my screen?
Yes, sir, we can see your screen, sir.
Okay. Next is covariance. Covariance measures how, what are the charts saying? Okay, fine. Covariance measures how two variables change together. Covariance measures how two variables change together. It is important to note that if covariance is positive, when x increases, y tends to increase too. And when x decreases, y tends to decrease. If covariance is negative, when x increases, y tends to decrease, opposite direction. If covariance is near zero, the implication is that there is no clear pattern of moving together. And the formula for a data set of n paired values, x, I, y, I, the meaning of xi is, let's say you have 5 set of numbers in a distribution. So in this case, we have x1, x2, x3, x4, x5. When I mean x1, I mean x subscript 1, x2 is the meaning is x subscript 2, x subscript 3. So that's why, since we don't have a defined data here, we are saying xi, xi. Now, the sample covariance. We have what we call sample covariance and population covariance. Sample covariance is given by curve xy. That is the covariance of the variable x and y is equal to the summation from I equal 1 to n, xi minus x bar, yi minus y bar, all over n minus 1. Here in this formula, your xi, just like I was explaining, if for instance you have like 5 set of data, it's your x1, your x2, your x3, your x4, your x5. Your x bar is the mean of x. Your y bar is the mean of y. Your x bar is the mean of x. Your y bar is the mean of y. Sorry, somebody just sent a very long note here. Your group, your group is. What is Julius saying? You group by. I don't understand what Julius Musa is saying. Now the population variance in this case, we have what we call the sample variance and the population variance. So, and the formula for sample variance, just like I said, is divided by n minus 1. For population is divided by, you divide by n. So, if you are given a question just like in this example 1, I just target positive covariance. A researcher recorded the hours studied X. A researcher recorded the hours studied X and test scores Y for 5 students. The students are labeled 1 to 5. The X hours are 2, 4, 6, 8, 10. And this is the implication of what this table is saying. The student that put in 2 hours in his studies got 55%. The student that put in 4 hours in his studies got 60%. The student that put in 6 hours in his studies got 65%. The student that put in 8 hours in his studies has 70%. That's an A. And the student that put in 10 hours in his studies has 75%. Where do you belong? Susan, I hope you belong to 8 hours to get 70%.
Yes, sir.
So this, I intentionally brought this example to tell you something. The student that put 2 hours got 55%. The student that put in 4 hours got 60%. The student that put in 6 hours got 65%. The student that put in 8 hours got 70%. And the student that put in 5 hours got 75%. So I would advise that you put in more hours in your studies so that the performance can be better. And it agrees with reality. The moment you put in uh, huge hours, you get huge results. Sorry for the population variance. Xi is still just like in this formula, and your mu x is simply telling you is the mean of x. It's the same thing there, but just in a different form. Mu x simply means the mean of x, and mu y simply means the mean of y. The mean of y is the same thing we're saying. Okay, please assume your screen. Okay, let's zoom the screen. Is it better now?
Yes, sir.
Okay. Now, the 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 question says find the sample covariance xy. That's the covariance of xy. Find the sample covariance. As you can see, we are specific that you should find the covariance xy. B, state whether it is positive or negative. You have to state whether it's positive, negative. You have to state whether it is positive or negative. Now, as a solution, sample covariance formula is given by of x, y is equal to the sum n. I is starting from 1 to n. In this case, let me be interpreting this term so that you know. I is equal to 1 to n. In this case, our n is 1, 2, 3, 4, 5. So our summation is from I equal 1 to 5, x I minus. Abu Elijah, I'm in the office. I'm having a Zoom class. If you are coming, just come. So, in this case, our n here is 1, 2, 3, 4, 5. So n here is 5, and here n is 5. So that will be 5 minus 1, which will give us 4 when we're substituting into the formula. So You find the mean of X.
Sorry, class. Let us exercise some patience. It's like Doc is having some network challenge, so let's wait. Hello, sir. Please, you can unmute. Unmute your mic.
Can you hear me now?
Yes, sir.
So, as I was saying, the very first thing you do here is to find the mean of x and the mean of y. Obviously, the n is 1, 2, 3, 4, 5. So, the very first bootstrap you take here is to find the mean of x, and the mean of x, is 2 plus 4 plus 6 plus 8 plus 10, divided by 1, 2, 3, 4, 5. Divided by 5, you have 30 over 5, which is equal. And the mean of y, you sum all this up, you divide by 5, you will have this all over that, equal to 65. So, finding the covariance, sample covariance, the very first thing is to get the mean value of x and the mean value of y. Now that we have the mean value of x and the mean value of y, is to substitute into this formula. So if we substitute into this formula, we'll have these are all the values of x. Just like I told you, xi is simply 2 is x1, 4 is x2, 6 is x3, 8 is x4, 10 is x5. So you arrange all the values of x, all the values of y. The next thing you do is to find the deviation from the values of x. Your mean of x, so it's simply taking 2 minus the mean, you have minus 4. The mean is 6. Note that the mean is 6 and that's the x bar is 6, y bar is 65. So the mean, you take this 2 minus the mean, you have minus 4. Y, 55 minus the mean, which is 60, you have minus 10. This column, the values of this column times the values of this column, you have 40. You go to 4. 4 minus the mean, you have 2 minus 2, 60 minus the mean of y bar minus 5. Note that I told you that the mean of x is 6 and the mean of y is 65. So 4 minus the mean, you have minus 2, 60 minus the mean, you have minus 5. Of course, you know that is 4 minus 6, which will give you minus 2, is 60 minus 65 is minus 5. So 2 times minus 2 times minus 5 gives us 10. So that's what you're going to do all through to this point. 10 minus the mean, which is 6. You have 4. 75 minus the mean, which is 65. You have 10. 4 times 10 gives us 4. Next is to add this column, because the formula says we should add the whole of this column, which is some xi times this, which will give us 40 plus 10 plus 0 plus 10 plus 40 is 100. And divide by n minus 1, because we're talking about a sample. If it's a population, it's divided by n. Since it's a sample, it's divided by n minus 1. So what you do is for xy is equal to 100 all over. You know the number is 1, 2, 3, 4, 5. So our n is 5. Our n is 5, so that's 5 minus 1, which will give us 4. So 100 all over 4 gives us 25, which is positive. The value there is. So on this example, any question? If you have any question, you ask. So the question, the B part says whether it's positive or negative. So it's positive, and we'll fix positive. So ask your questions, please. So
Tabitha,
this is
can
2 o'clock.
ask your question.
Now,
Tabitha,
Tabitha, ask your question.
Sir.
Afternoon.
Sir, please, I don't know if you can still go over it again because network kicked me out. So I don't understand from this x minus s and then y minus y. I don't know.
What your colleagues are saying. This is what
Yes.
your colleagues are saying, that mathematics is not good in the afternoon. And I have a challenge tomorrow morning. Tomorrow morning, I have year 1, 8 to 10. So if we should
Okay.
choose, can we have the class in the evening? It's just for tomorrow only, so that I can teach this year 1. Class
Yes,
rep.
sir.
If you prefer 4 to 6 or 3 to 6, anyone you choose. You will settle and get back to me, isn't it?
Yes, I'm going.
So people are saying 4 to 6. Get your preferred time and get across to the class rep. The class rep will get to me. I will go over this again tomorrow, don't worry. So, since it's 2 o'clock,